Hi, and welcome to Matrix Algebra. We're not going to be actually solving any systems today. What we're going to be doing is combining matrices with other matrices just for funsies, not to actually do anything in particular. So matrix addition and subtraction, very straightforward. Nothing really crazy going on here. You just take each spot in the matrix and add it to the corresponding spot in the other matrix. Now, the thing is, the matrices have to be the exact same size and shape. So if you got a 2 by 2, you can only add it to a 2 by 2. If you got a 2 by 3, it can only be added to another 2 by 3. You can't do something like 4 by 5 and then add it to a 2 by 3. Mel is really objecting to that now, isn't she? I don't know if you could hear her. Here she comes. So we want to take these two matrices, we want to add them together. Right, Mel? Yeah. So we want to do matrix A plus matrix B. We're also going to subtract the two of them. So I got A, and I want to add that to matrix B. You're not very helpful as I'm trying to add these matrices. You need to go on the floor. Matrix A plus matrix B. So I take all of the corresponding spots and I add them together. So I need to do this -4 plus 2. -4 plus 2 gets me -2. Then I also need to do 5 plus 3. So that is 8. And then I need to do 3 plus -1. She's back, which gets me 2, just regular 2. Now on the test, I will ask you to show like a little bit of work about like what you're doing here. Hey, right? So what we want to do is just, at least for the first row, we want to write how we did these calculations. So we did -4 plus 2, 5 plus 3, and 3 plus -1. Oh, thank you. I'm glad that you like me. We don't need to go through and do the whole matrix. If you check the PDF notes, I actually do the whole matrix like this. You don't have to do that. You can just make a little note like that, and then I kind of get the picture. And then I'll just kind of check the rest of the numbers. But I need you to show that you know how we got these numbers and that you didn't just like kind of type them into the calculator. Oh, look at you. You're going to show me your belly. Okay. I got to do the second row. So 1 plus -4. I'm not going to mark it this time, so that's -3. 2 plus 0, that's 2. You are really just not, this ain't working. This ain't working, Mel. All right, now we want to do the same thing, but we want to subtract. So we want to do matrix A minus matrix B. And so what we want to do is the same thing as before. And we'll write that little notation. I'm going to do it for the bottom row this time. It just needs to be some row that you're showing me how you're getting these numbers. So I need to do 1 minus -4, which makes it a 1 plus 4. And then we got to do 2 minus 0 and 7 minus 12. Those aren't actually in the matrix. You're just showing like, okay, this is what I was doing in my head. I want you to do them in your head, but I can't see what's going on in your head when you're writing stuff down on a piece of paper. So I need you to write something down, and that's just me. So I got -6, 8, and 3 minus -1 should get me 4. And that's how I add and subtract those matrices. Matrix multiplication, however, is a little bit more complicated. We can multiply it by a scalar. Sorry, this one's super easy. You just multiply all the numbers by the number that you got there. So 5a is just going to take all of these numbers here, and we're going to multiply them all by 5. Bop, 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 bop. So 5a gets us -5, a 10, a -15, and a 20. If I'm doing 2b, just multiply all of these numbers by 2. So 2b is going to be 0 to -4 and 6. And then it's also asking us to add those two matrices together. So 5a plus 2b, b is going to equal just those parts added together. I'm going to do a sample row. I'm going to do the bottom one this time. I'm going to do that again. So -5 plus -4 and 20 plus 6. So that's 26. That's -19. This is -5. And this is 12. If you wanted to put that on all of the spots, I'm not going to stop you. I just need to see it in at least one row that you're showing how did you do that. And you can see I'm showing how I did that multiplication using that top matrix. Okay, now this is the thing I was thinking about. When you multiply matrices together, you have to check a couple things. First, you need to check to make sure that it's the appropriate orientation of matrices. So this is a 1 by 2 matrix. It has one row and two columns. The other one has two rows and one column. You need to make sure that these two numbers are equal to each other. If those two numbers are not equal to each other, then you are not allowed to multiply the matrix. Your resulting matrix is going to be these outside numbers. We're going to end up with a 1 by 1 matrix. And you can see that right here, a 1 by 1. To do that, you find each spot by going across the rows and then down the column. So you kind of make this sort of sliding move. My left and rights are going to be all backwards because of how this is recorded, but you need to move across the rows in the first matrix and then down the columns in the second matrix, multiplying each spot and then adding that together as a sum, and that will get you each spot. And let's do one of these so we can see what's going on. So I have a 3 by 1 matrix here. Excuse my phone. And my other matrix, I'm going to silence that, is a 1 by 2. Those two things are equal to each other. So yes, I am allowed to multiply these two matrices together. My new matrix is going to be these outside numbers. I know it is going to be a 3 by 2 matrix. It will have 3 rows and 2 columns. So 3 rows and 2 columns. Okay. Then I'm going to write these two matrices over here on the side. 1, 2, 3. And 4, 5. Now it's going to look a little goofy when I do these moves because I'm not going to move anywhere. I need to go across the rows in this one and then down the columns in the second one. So when I do the first spot, I go across the first row and down the first column, but that only produces one number, 1 times 4, which is 4. Then, here, actually, I'm going to undo that so that I can just circle the rows I'm working on. So this is 1 times 4, which is 4. Then I need to go to, maybe I want to work on the next row. So I'm going to increase my rows. And I'm staying in the first column, so I'll stay in the first column. 2 times 4 is going to get me 8. Then maybe I want to go down one more row. So I'll increase the one where I'm going across the rows. And I'm staying in the first column, so I will stay in the first column. 3 times 4 is going to get me 12. Now, when I move over to the second column, increase the columns. So I'll go to the second column, the one I moved by column, and keep the one where I moved by row. So this one will be 1 times 5, which is 5. Next, I want to go to the second row. So increase the rows. And I want to go to the second column. So second column. 2 times 5 is going to get me 10. Whoop. Come on, undo it. Just undo it. That's all you got to do, 10. Then the last one is I need to do the third row, third one that I go by row, and second column because it's in the third row and the second column. 3 times 5 is going to get me 15. And there is my product. We'll need to do another one of those, I think. Let's reverse it, and we'll at least try to reverse it. So again, this is a 1 by 2 matrix because it has 1 row and 2 columns. And then this one is a 3 rows by 1 column. Since these two numbers don't match, no good. That is not true. 2 is not the same as 3. So BA does not exist. We are not able to multiply those two matrices together because the 2 and the 3 don't match. I can't multiply those together to make a 1 by 1. You can't multiply any old matrix by any old matrix. Let's do one where we actually have to do a couple more spots though. So I want to find AB. So I want to multiply these two matrices together. So I'm just going to write it over here. Oh, first I got to check, sorry. I have 2 rows and 3 columns in A. And then in B, I have 3 rows and 2 columns. These two things are equal. 3 is going to be the same as 3. So I am allowed to create a matrix. It is going to be a 2 by 2. So I'll make a little matrix over here where I'll put all my numbers and stuff. I'm going to make it a little bit bigger because I think I'm actually going to write out what I'm doing in this one. So 0, 2, -3, -1, 4, 0, -1, 1, 2, 0, and -2. Okay. Now I always like to draw these little guide rails to help remind me what I need to do. I would also really recommend that while you do these, you actually drag your fingers across the paper so you can do the slides. It's a lot easier to figure out what you got to do as you're working through it. So one finger goes across and the other one goes down. So it kind of does a whoop at the same time. But it might be like that. I got my left and rights are all goofy. No, I think it's actually right because you can read my shirt. So if I make sure it looks right in this, then we should be fine. So it will be like this, right? I don't know. Just stop. Just stop. So in order to do the first one, I need to use the first row. So here's my first row. And I need to use the first column. So I'll use the column of this one. So I'm going to multiply all those spots in that row by all those spots in that column and add all of those products together. So I've got 1 times 0, that is 0, plus 0 times 1, which is 0, plus 2 times 0, which is 0. So it's just a whole bunch of zeros for that one. If you need to rewind, look, have me talk through that again. If I want to move on to the second row, I'll grab the second row on this one. I want to stay in the first column because I want to try to take care of this spot right here. So I will use the first column. In my answer matrix, I am in the second row, first column. So I'm going to use the second row, first column of my two product matrices. All right, so -3 times 0, that's 0, plus -1 times 1, that's -1, plus 4 times 0, which is 0. All right, let's say I want to move on to this spot right here. So that is in my second column. Grab the second column of the column E matrix, and it's in the first row. So I will use the first row. First row, second column, my products will get me my first row, second column of my answer matrix. So, I'll erase that. I want to do 1 times -1, which is -1, plus 0 times 2, which is 0, plus 2 times -2, which is -4. All right. Notice I'm also writing all of these out for this one, like especially for the multiplying ones. It's kind of nice to have that as a nice reference if it's not matching the answer on your calculator, because you can still do these in your calculator. I will still require that you write at least one row when you do this on the test, so I know what you're doing in your head. So I want the second row, second column of those two matrices. So let's go through it. Come on, go away. -3 times -1 is 3, plus -1 times 2 is -2, plus 4 times -2 is -8. Okay. Now let's add all those together and see what our cool answer is. So it's equals and equals. So first spot we have 0, -1, -5, and that's -10 plus 3, that's -7 for our answer. Now, some general properties to know about with these matrices. So some of these are pretty important, other ones, and I'll kind of move them around so that you're most familiar with them. The ones that I really want you to know about are these top two. That if you're adding two matrices together, if you would like to, you can reverse the order of them. That'll work out okay. Something I want you to know more importantly is that you can't reverse multiplication. Order really, really matters when you're multiplying matrices together. If you think back to that first multiplication example that we worked on, hi Mel, we were able to multiply A times B, that was perfectly fine, but then if we reverse it, then we are not even able to multiply. Some of them aren't quite that bad. You can multiply in both directions, but your product is going to be different when you are done. Now, this kind of dominoes into a bunch of other ideas where like you can reverse, like if you've got addition, but if you've got like a product, then this order really matters, like where that distribution is happening. I wouldn't worry about these ones too much. This one is kind of cool, where you can move those parentheses around if you would like. You can add a 0, so you can make a 0 matrix. That works okay. And you can add two matrices together with their opposites to create a big 0 matrix. However, you aren't able to multiply a matrix with its inverse together to create 0. That's going to make something else, and we'll talk about that next time. It's something called the identity. That's about it for this stuff. There is going to be a little bonus video that you can check if you want to see another example of me doing this operations and how to do these products. So catch you later. Mel says bye-bye. Say bye-bye, Mel.